Good afternoon. In this video, I'm going to teach you how to prove a relation is a function by using a table of values. Alright? First of all, what is a function? We need to know what is a function. Okay? A function is every input has exactly one output. For example, when we talk about input, we see the values of x. Okay? The x values are the input. Okay? The y values are the output. In order to have a function by using a table, every input must have exactly one output. If you see one output has two, or one input has two outputs, that means this relation is not a function. Okay? That's what we're going to prove today. Okay? So, before we do that, let's see some definitions. Let's see. Okay. First of all, a function is translating as every input has exactly one output. Let's see what is a relation. A relation is a set of input and output. For example, all these tables are the relations because they are input and outputs. Okay? So let's see the third definition. Mapping. Mapping is shows how the elements are paired. For example, you see the mapping 0 map to 1 and 2 map to 3 and negative 2 map to 4, etc. Okay? So we're going to prove these tables are the functions, or we can say we're going to prove the relation if the relation is a function. Okay? So let's start with the first example. So the first example, this is the first table. This is the value of x, 4, negative 5, and 2. The value of y, we have negative 6, 3, and 2. We're going to see if this table is a function. Okay? So the one says every input has exactly one output. When we see 4 map to negative 6, negative 5 map to 3, 2 map to 2. For example, because we see every input, okay, every x has exactly one y, we can see this table is a function. Okay, that's why that, okay, is a function. Is a function. The first table is a function. Okay. So, it's simple. If you see every x has exactly one y, you can quickly say, alright, this function, this relation is a function. Let's see number 2. Number 2, we have 0 map to 1, 2 map to 3, negative 2 map to 4. When I check, we see every input has exactly one output. Or we can say every x has exactly one y. Because of that, we can say this table is a function. Okay? That's a function. Okay? That's the function. Very good. The third exercise. Let's see. So we have 2 map to 4, 3 map to 5, 2 map to 6. We have a problem right here. We have a 2. Here we have another 2. Because we have two identical numbers, they are the same, but they map to different y. Okay, you see? 2 map to 4, the same 2 map to 6. So we can say this is not a function because the rule says every x must have exactly one y. So this table does not translate these rules. For example, you see 2 and another 2. So this is not a function. This is not a function. This is not a function because 2 and this 2. Alright? We clear about that. It's not a function. Let's see the fourth tables. The first table, we have 4 map to 1, 5 map to 3, 4 map to 5. And when we look at this table also, we see two identical numbers. Okay, two identical numbers, 4 and another 4. They are the same. But because they are the same numbers, they are mapping to different y. Okay, they are mapping to different y's. We can say this is not a function. Okay, you see the x map to 1, the same x map to 5. They're not the same. Okay, so this is not a function. This is not a function. Alright, this is not difficult if you know this word. What is this word? So the word say every input has exactly one output. Every x must have exactly one y. If you see there are 2x, okay, 2x, or you see 2x mapping on two different y, so this is not a function. Alright, I believe you will understand that function, that's the beginning of this function. The introduction of function is always easy, but wait for other exercises regarding other function. So if you have questions, go to my website or just type NuGet Math and then everything will come out. Okay, everything will come out. Please share my videos. When you share my videos, you help me grow. You know, I will be there to build free math video for you. Thank you so much.